Have you ever stopped and wondered what's really going on inside the mind of an AI? I'm not talking about the slick user interface, but the deep, hidden world of how a machine actually reasons, what it believes, and how it knows what it knows. It's one of the biggest challenges in computer science. How do you build a logical mind completely from scratch? So you know what? Let's do it. Let's build an AI's mind from the ground up, and then see where it breaks. So here's our game plan. We're going to start with how an AI knows anything in the first place. Then we'll tackle the tricky difference between its knowledge and its beliefs and how it actually changes its mind. After that, we dive headfirst into the mind-bending paradox of truth, and we'll see if there's any way to escape the loop. All right, so where do we even begin? Well, first things first, we need to give our machine the basic tools to reason about the world, and more importantly, to reason about its own internal state. I mean, this is the central question, right? It's one thing to program a computer to crunch numbers. That's easy. But it's a whole other ballgame to program it to think about abstract stuff like knowing or believing something. How on earth do you translate a fuzzy human concept like belief into cold, hard ones and zeros?
Well, the answer, it turns out, comes from a field called modal logic. Think of it like a special grammar, but for ideas, not just words. It gives us a super strict set of rules to define these kind of hazy concepts, like possibility or belief, in a way that a computer can actually understand and process. The best way to think about it is like we're giving the AI a set of different lenses to view the world with. Through one lens, it can look at a statement and ask, okay, is this thing even possible? Then it can swap to another lens and ask, or is it absolutely 100% necessary? This ability to switch between what it believes and what it knows for sure is the bedrock of machine reasoning.
And using those different logical lenses right away forces us to make a really crucial distinction. The difference between what an AI truly knows and what it simply believes. They are not the same thing.
These two concepts are so important they actually get their own branches of logic. On one hand, you have epistemic logic. This deals with capital K knowledge, things that are certain and, by definition, have to be true. Then, on the other hand, you have doxastic logic. This deals with beliefs, things the AI thinks are true, but, well, it could be wrong. It's like I can believe it's sunny outside, but I only know it's sunny after I actually get up and look out the window. For an AI, that distinction is everything. And believe it or not, it gets even crazier when you throw multiple AIs into the mix. Suddenly, the logic has to handle what an entire group knows, or what information is announced publicly. It even has to deal with this wild idea called common knowledge. That's the recursive thing where everyone knows the traffic light is red, and everyone knows that everyone else knows it's red. Without that deeply shared understanding, you just get chaos. And the exact same is true for a team of AIs trying to work together.
Now check this out. Here's a really elegant twist. You can actually build the idea of belief right on top of knowledge. In some advanced systems, an AI believes something for a very simple reason, because it knows that statement is more plausible than the alternative. It's a really powerful and honestly intuitive way to link these two big ideas together. Okay, so we've built a mind that can know things and believe things. But what happens when it learns something new, something that completely contradicts what it thought was true? How does an AI change its mind?
I mean, this is what really separates an intelligent agent from, say, a glorified calculator. It has to be dynamic. Like a detective working a tough case, it can't just ignore new evidence. It has to constantly update its theory of the crime. The real challenge, though, is figuring out how to fit that new clue into the story without making the whole case just fall apart into a mess of contradictions.
A really common framework for this is called the AGM model. It's pretty straightforward. The AI starts with a nice, consistent set of beliefs. It gets some new info. It works to revise its beliefs to fit that new info in, and then it runs a check to make sure the whole system is still coherent. Seems logical enough, right? Well, yeah, here's the big catch. The basic model has a massive flaw. It assumes the AI is just incredibly naive. It just accepts any new piece of information it's given, no matter how wild or crazy it sounds. For a truly rational agent, that's a pretty unrealistic and, frankly, dangerous way to operate. So to build a smarter, less gullible AI, logicians basically had to come up with an upgrade. With something called credibility limited revisions, the AI finally gets a bit of a backbone. It can now weigh new information against its most deeply held core beliefs, and it can actually decide to reject the new data if it seems totally unreliable or contradictory. This is a huge, huge step toward a more realistic artificial mind.
All right, now we get to the real mind-bending part of our story. We've built this powerful, elegant system of logic. But what happens when we turn that system inward and ask it to reason about itself? This is where things get really, really strange.
It all boils down to one simple but unbelievably powerful and dangerous concept: self-reference. When a system of logic tries to talk about itself, this is the granddaddy of all paradoxes, the liar paradox. Just think about that for a second. If the sentence is true, then what it says must be correct, which means it has to be false. But okay, if it's false, then what it says is wrong, which means it must actually be true. It's an impossible, infinite loop. True, no, false. Wait, true. A computer trying to solve this will literally be stuck forever.
This kind of thing is called a semantic paradox. And for an AI, it's basically a logical black hole. It's a command that the AI's own operating system just can't process without crashing. The very rules of logic that gave it all its power are now forcing it into a contradiction that has no escape.
And look, this isn't just some clever party trick with words. This problem is directly tied to one of the most profound and mind-blowing discoveries in the history of mathematics, Gödel's incompleteness theorems. The takeaway from that is just staggering. It means that any system of logic, no matter how powerful or perfect you try to make it, will always have built-in limits. There will always be true statements that the system is simply incapable of proving.
So is that it? Is logic just fundamentally broken? Is the whole system a bust? Well, not quite. Logicians and computer scientists, they're a pretty clever bunch, and they've figured out some ingenious ways to kind of work around these paradoxes, to tame them so they don't bring the whole system crashing down. There are basically two main escape hatches. The first one is called typed systems. This creates a kind of hierarchy of language. Essentially, a statement isn't allowed to talk about its own truth value. That's a job for a higher level of language. It's like saying you can't use the rulebook to judge the rulebook itself. The second route, non-classical logic, just changes the rules of the game. It says, okay, forget just true or false. It adds a third option, a kind of maybe or undefined, that you can assign to these paradoxical sentences.
And you know, figuring this stuff out isn't just some abstract puzzle for logicians. This same pattern of self-reference, these loops, they show up everywhere. From analyzing how complex AI programs are, to modeling strategic games where each player is trying to outthink the other person's outthinking, and even in the escalating logic of real-world arms races.
So we end up here. We've seen how we can build this incredible logical mind for a machine, only to find out that the very idea of truth can tie that mind into an impossible knot. And it leaves us with one last big question to chew on. If even our most rigorous, formal systems of logic struggle with these fundamental paradoxes of truth and self-reference, what does that say about our own, far messier human minds? What are the limits of our own reasoning? Something to think about.